going to do some more examples, and I'm going to do this one two different ways. I'm going to use the table method that Delta Math likes to use. I'll also use a tree diagram and show you how it can be used both ways. So LaGuardia is an airport in New York. So at LaGuardia, for a certain nightly flight, the probability of rain is 0.07, and the probability the flight will be delayed is 0.18. The probability that it will not rain and the flight will leave on time, which means it would not be delayed, is 0.8. What's the probability that it is raining if the flight has been delayed? So in this, we could do it a couple different ways, and I'm going to do some simplifying on this. So we're going to talk about it's either raining or it's not raining. So that little symbol right there means not. Okay, so it's either raining or it's not raining. It's either delayed or it's not delayed. Okay, so just the same kind of thing as that's just a symbol. Okay, so when we talk about this, notice that this down here is going to be 1 because it adds up everything that would happen. So the probability that it will rain is 0.07. So the probability that it's going to rain is 0.07. So that's the rain column, right? So this is the rain column, which means that the not rain is going to be 0.93 because it's either raining or it's not raining, and they have to add up to 1. The probability that the flight will be delayed is 0.18. So you know that the probability that the flight is going to be delayed is this delayed column. That's 0.18, which means that the probability that this flight is not going to be delayed is 1 minus 0.18, because it's got to be, those two things have to add up to 1, and it makes sense. It's either delayed or it's not delayed. And so that's 0.82. Okay, because 0.18 plus 0.82 is 1. Now the last thing is the probability that it will not rain and the flight will leave on time, so it's not delayed, is 0.8. That's this value right here. Because that's that box right there represents not rain and not delayed. That's what that represents. And that's what it's saying in here. The probability it will not rain and the flight will leave on time, which means it's not delayed, is 0.8. Now, we have everything we need, because when you think about like backing this up, when we think about the parts in here, we know that 0.82 minus 0.8 should give us this value, which is 0.02. Now back this up a little further. If we know that 0.07 minus 0.02 would be this box right here, so that one's 0.05, because together they have to add up. And then finally, you could calculate this last box any way you wanted to, but 0.18 minus 0.05 has to be 0.13. And if you look at 0.13 plus 0.8 is 0.93, and so we have everything we need. So the question then on this particular one is, so the question we're asked on this is, what is the probability that it is raining if the flight has been delayed? Probability it's raining given that the flight is delayed. Okay. So the probability that it's raining given the flight that it's delayed. Well, given that it's delayed is the 0.18, right? It's delayed 18% of the time. The probability that it's raining given that it's delayed is the 0.05. So if we take that 0.05 divided by 0.18, if we do that on a calculator, I'll do that real quick. I'll do 0.05 divided by 0.18. I get 0.278 rounded to the nearest thousandths. So that's the way I would probably do this type of problem, is I'd use that that figure. Now, we could also do this using a tree diagram. It's not quite as easy, but I do want to show you that a tree diagram could be used on this. Let me make sure that I have the right answer before I go on here. 278. And there's the answer. So here's another way of dealing with this, is you could say, okay, the probability that it's raining is equal to 0.07. So that means the probability that it's not raining is equal to 0.93. So if we're doing a tree diagram. Now, with this tree diagram, is we can do a little bit more. The probability so this last piece, the probability that it will not rain and the flight will leave on time is 0.08. So we'll say delayed here and not delayed here. So down here we could have delayed and not delayed here. So the probability that it will not rain and the flight will leave on time would be this box right down here, which in that case is 0.8. Now, if you think about what would happen on this, so the question is, what's the probability that it is raining given that the flight has been delayed? This is going to be pretty challenging, so I'm probably going to stop here, but this is the kind of tree diagram that you would set up. I actually think in this case, it's probably easiest to just do that box thing. So let's just leave it at that. Let's look at the verbal description on this one. This one right here, we could do a box. We could also maybe do a Venn diagram on this one. You got a math class, you got 23 students. Test was given on the day. There are 15 students who passed the test and 18 students who completed the assignment. Okay. There were 13 students who passed the test and also completed the assignment. So you got passed, and you know there were 15 students that passed the test, and you know that completed, and you know there were 18 students who completed the assignment, and you know 13 of the students passed and also completed the assignment. So what's the probability that a student chosen at random from the class failed the test and did not complete the homework? So if we think about this grouping, we know that there is 2 students that passed but didn't complete the assignment. We know that there are 5 students that completed the assignment that did not pass the test. So the question that we're asked on this is, what is the probability that a student chosen at random failed, okay, and did not complete the homework? Well, isn't that the people that aren't in this box here, right? I mean, if you think about all the people that are outside here, anybody who's that's not in those circles, they didn't pass and they didn't complete the homework. So when we think about those people, out of the 23 total students, they're the people that are left over out here. Well, when you think about it, you got 13 plus 5 is 18, plus 2 more is 20. So we got 3 students out here that fall into that category. So hopefully it's 3 out of 23. And they do it using this box method. If you like that better, go ahead and use that. Last thing is this compound probability, and we will use a tree diagram on this one. So we'll get all of the things on this one. So let's use a tree diagram on this one. You got 5 red marbles. You got 3 blue marbles. And you got 6 green marbles. So total in the bag, you got 8, 14 total. Okay. So 3 marbles are drawn out of the bag. What's the probability to the nearest 10th of a percent, so that's 1 decimal place, that the 3 marbles will be red? So let's think about what could happen. If we drew a tree diagram on this, and I'm going to draw the tree diagram like this, we could pick a red one, a blue one, and a green one. Now we're supposed to pick again, right? Because we're picking 3 marbles out of here. So we could pick a red, a blue, and a green. We could pick a red, a blue, or a green. We could pick a red, a blue, or a green. Now, as you get a bigger and bigger tree diagram, it makes it a little bit more challenging to figure out, to draw the whole thing, right? I mean, they get pretty big, especially when you have three things. But notice the question is that all 3 marbles will be red. Well, that's only one thing over here, right? I mean, that's only this one right there. It's only this box right here at the bottom of this part of the tree. So that's the only one we're concerned about. Now, if we go back, we know that picking a red marble the first time out of this bag is 5 out of 14. Now, but we're picking all 3 marbles at the same time. So once it's almost like picking one, don't look at it, pick another one, don't look at it, pick another one, don't look at it. So the second time we go into the bag, there's only 4 left out of 13 because we've lost 1 marble out of there. And the last time we go in, there would be 3 out of 12. So the final answer down here is 5 out of 14 times 4 out of 13 times 3 out of 12. Now we gotta answer this. What's the probability to the nearest 1/10 of a percent? So we do have to calculate this. And if I calculate this using my calculator, 5 out of 14 times 4 out of 13 times 3 out of 12, I'll end up with 0.02747, which is approximately 2.7% to the nearest 1/10 of a percent. So I think if I do 2.7 on here, I think that's what they're going to expect me to write down, and that's it. And they'll go through and show you the same calculations that I did. Hopefully that makes sense. If you have questions, let me know. But now you've seen the box method, you've seen a Venn diagram, and now this one's a tree one. So all three are really good methods of organizing the work.